All right, welcome. So we're on Unit 7, Exponent Properties. We're spending a couple weeks working on that, review and take the test. Dates may change based on how things are going, but this should be good. All right, so here we go. This is for Lesson 7.1, Simplifying Exponents. All right, so before we get into anything else, we should probably talk about what are exponents. And I think you've used these before. Something like 2 squared, well, that's 4. 3 squared, that's 9. Okay, so those would be our exponents. Something like that. That would be our exponent. Okay, so let's talk about a few definitions. Okay, so base is the number or variable under the exponent. So in this situation, to your right, this would be our base. For this situation, the base is a variable. We could have another example over here where the base is 2, and it's a number. Okay, an exponent is the number that tells how many times the base is being multiplied by itself. So on this example I wrote here, right here, 2 to the third, well, that's just telling us that we need to multiply the base, which is 2, by itself 3 times. So 2 times 2 times 2. All right? If we were to, for this example here, that's telling us that we need to multiply x by itself 3 times. So x times x times x. All right, so this is our exponent, and this is our base. Okay? And they're always a pair. You can't move something else, like you can't move the base and leave the exponent, and you can't move the exponent without moving the base. Okay, so they're like a pair. Okay, and then last we have coefficient. So coefficient is the number in front of the base. So in this example, this would be our base, our coefficient. Okay. All right, and if there's not a coefficient, then it's always going to be 1. So here's an example of an expression where the base would be, or the coefficient would be 1. So here, our base, I want you to write down, fill these in and say, or what each of them are. So here the base would be 4, exponent would be 3, and the coefficient here would be 1. Okay? Be like 1 times that. Some of you guys, some of the students asked if that would be 0, okay? But if this was 0, then the whole thing would be 0. So here the coefficient has to be 1. Here's another example. A base would be x, the exponent would be 7, and the coefficient in this example would be -1. So we could rewrite this as -1 times x to the 7, if that makes more sense to you. Okay? Next, we have a base of x, an exponent of 2, and a coefficient of 5. Base of x, exponent of 12, and a coefficient of 1. And then here we have a base of x, exponent of 2, and a coefficient of a -7. Okay? So for that, it should be fairly simple. Let's do some examples. So here they want us to simplify the expression using an expanded form. So expanding an expression is like this one right here, where we have 2 to the third. Okay, to expand it, we would just rewrite it as 2 times 2 times 2. So in this situation, we have 7 to the third. Well, that's just 7 times 7 times 7. And then we want to simplify. So you'd plug that in your calculator, or you could do some math and you'd find out that it would be 343. Okay? So this would be our expanded, and this would be simplified. Okay? So here are just some others. If we expanded that, that would be x times x times x times x. So x, we multiply x by itself 4 times. Okay, and if you simplified, it would just give us the same answer, x to the 4th. All right, next we have 2x to the 3rd. So remember, this exponent only applies to what's right next to it. So in this situation, if we did expand it, it would be 2 times x times x times x. Okay, if you'd like, you could put a little dot in between to show that they're separate. Okay, just that's probably one of the most common mistakes, is thinking that you can, that this would be the same as our next example. Let's just look at the next example. So these two examples are the same, except for we have a parenthesis. So in this situation, if we expanded that, that would be 2x times 2x times 2x. And that ends up giving us 8x to the 3rd. So 2 times 2 is 4, times 2 is 8. Okay? And then we get x to the 3rd. All right? So, like I said, when we do exponents, that's what we're really doing. We're multiplying the base. In this situation, the base is 2x. And we're going to multiply by itself 3 times. Some people try and simplify this by distributing the exponent, writing that as 2 to the 3rd and x to the 3rd. Oftentimes that works, but not always. So you can only, again, when you have exponents, that's what we're doing. We're multiplying the base by itself that many times. Okay, if it helps you, you can think of it as distributing, but it doesn't work all the time. So if we had an example of x plus 1 squared, that is not equal to x squared plus 1 squared. Okay, so whenever you have addition or subtraction with your exponents, then you definitely cannot distribute the exponent. Okay, because really what we need to do is do x plus 1 times x plus 1, and then evaluate. Okay, and we'll talk more about that in the future. Oops, my bad. Hang on, go back, please. Notes. No, that is not it. Here we go. Okay, sorry about that. Okay. All right, I think that's enough said. And let's do some more examples. Okay. All right, so this is another example where you'd want to expand. So that's -3 times -3, which is a positive 9. Okay, and if you don't have variables, you're welcome to just plug that into your calculator. Okay, if you would like. I would probably suggest that you do it by hand, just so that you have more practice. Because when you have variables, you can't use your calculator like that. Okay, so these two are basically the same, except we have the parenthesis. So in this situation, we have negative. We could rewrite that as -1 times 3 squared. Okay, so this is our coefficient. This would be our base. Okay, so again, the exponent only applies to what's touching. It touches the 3, but it doesn't touch the negative. So we'd need to have -1 times 3 times 3 times 3. That would be expanded. Okay? And then to simplify, that would just give us -27. Okay? And these two are very similar without the parentheses. Here we have -x times -x by or 3 times. Okay? And that would end up giving us a -x to the 3rd. All right? Because here we have a negative times a negative. That gives us a positive. And then a negative times a positive gives you a negative. Okay? Here's another example, but the 3 only applies to the x. So we'd have negative. You could do a negative 1 if you'd like, times x times x times x, and that just gives you negative x to the third. So these two give you the same example, whether or not the parentheses there, and that only applies when you have exponents that are odd. Okay. All right. Okay, so here's some practice. I don't think we went over this in class, but if you'd like some more practice, then we can go over that, or you can skip on. Okay, so 2 to the third, that's 2 times 2 times 2, which is 8. Negative 2 to the third, well, that's just negative 2 times negative 2 times negative 2, which ends up giving us, and you can do this on your calculator too, like I said, that gives us negative 8. This gives us a negative, and then we have 2 times 2 times 2, gives you negative 8. Here we've got negative 2 times x times x times x. Well, that's negative 2x to the third. So this can't be simplified any further. And you'll have some on your homework that they're already simplified. All right, so this is negative 2x times itself 3 times. Okay, so we have negative 2 times negative 2 times negative 2, and if you wanted to do that on your calculator, that's fine. That gives you negative 8. And then x times x times x, that gives us x to the third. So this one is different than when you simplify it. Okay? Usually when you have parentheses, that's what's going to change. It won't be the same. So if you have variables and you have a parenthesis, I guess that's when you can simplify. Or if you have problems where there is no variable, then for sure you can simplify. Okay? 2 squared is 2 times 2. Negative 2 squared, well, that's negative 2 times a negative 2, which gives you a positive 4. Okay, again, these are different because this one doesn't have a parenthesis, so we have a negative, and then we're only squaring the 2, so we'd get 2 times 2. Okay, and you could write it as a negative 1 if you'd like, because that would be our coefficient. Okay, so negative 4. And then those two, or I guess those aren't the same. These two are the same except with a parenthesis. So here again we have, if you expand, okay, sorry. If you need to expand, we'd have negative 2, but the exponent only applies with the x, or the 2 only applies with the x, so we'd have x times x. Okay, and this one doesn't, it gives us the same answer when we simplify it. But this one we will get something different. So this is the same as negative 2x times negative 2x, which gives us a positive 4x squared. All right. So trying to speed this up a little bit more. I filled this in already. So in class we answered, we're filled in this table. This is just telling you what x we're using. So we'd plug in 2 for x, and that gives us 2 to the negative 3. Plug that in your calculator, you end up getting 1/8. And then we do the following for everything else. Here we'd get 1/4, 1/2. And then we get 2 to the 0. If you plug that in your calculator, you get 1. And then we get 2, 4, and 8. Okay, so we kind of see this pattern. If you start here at 8, you divide that by 2, you get 4. Divide that by 2, you get 2. Divide that by 2, you get 1. Divide that by 2, you get 1/2, and so forth. Okay, so there's this pattern. And we did this with the other ones as well when x is 3, x is 4, and x is 5. I didn't do for 10. It's just a little overkill, I feel. All right, and then we wanted to find out what we can find out from this graph. What happens when we have 0 exponents? Our exponent is a 0. Okay, so looking at these problems, 2 to the 0, 3 to the 0, 4 to the 0, 5 to the 0, okay? X to the 0 would be 1, okay? So what we discovered in class is that anything to the 0 is 1, all right? So here's some examples of what we did. X to the 0, we already did that at the top, so that's just 1. All right, 100,000 to the 0 power is 1, okay? If you have numbers, you can always plug those into your calculator and check. Next we have in a parenthesis, 5x to the 4th, y to the 12th, all to the 0th power. Again, that gives us 1. And then this one was one that many students kind of got stuck or were a little confused. Okay, many people said that the answer here would be 1. All right, but again, this exponent only applies to what's touching. So above, this was a parenthesis, so everything was all to the 0 power. But this last problem, only the x is to the 0 power. So that would be 3 times 1, which is 3. Okay, so just be careful when we have x to the 0 that it's only what's touching. Okay, and then we also discussed negative exponents. So if we look at this table, what do you notice the relationship between, you know, a positive exponent and a negative exponent? All right, so here we have 2 and here we have 1/2. What about positive 2 and a negative 2 for our exponents? Well, here we have a 4 and a 1/4. All right, so the relationship between a negative exponent is the same as a positive exponent. It's just it's reciprocal. Okay, so x to the 3rd is 8. X to the 1/3, or x to the negative 3rd is just 1/8. Okay, so here is the kind of like the equation or whatever we'd use would say that any base to some number that's negative, we'll just say a, could be 2, 5, 7, okay? That is the same as the same exponent that's positive, but it's reciprocal, okay? And it also works when you have something like 1 over x to the negative exponent. Well, we can bring that to the top and make that be positive, okay? All right, so just remember, whenever you have a negative exponent, you're just going to take the whole thing down. If it's already on the top, we'll bring it to the bottom and change its sign. If it's on the bottom, then we'd bring it to the top and we'd change its sign. Just the exponent is the sign that would change. Okay, so let's do some examples of that. X to the negative 1. Well, the exponent's negative, so we'd want to do its reciprocal. Okay, but then we'd want to change its sign, so it would become a positive 1. Right? And you don't need to write down x to the positive 1. That's just the same as x. Okay? And we kind of did that on our table here. All of these, 2 to the 1 is 2, 3 to the 1 is 3, 4 to the 1 is 4, 5 to the 1 is 5. Okay, so whenever you have something like x or a number to the 1, it's just simplify it further and just say it's just that number, or x is just going to be x instead of x to the 1. Anyway, all right, so here's another example. It's a negative exponent, so we'll do its reciprocal, and then we'll change its sign. So that would give us a positive 1. Okay, next. Again, this exponent only applies to that x. So the 2 is going to stay up at the top, but we'll bring the x down and change its sign. Okay, here's some others where the exponent's in the denominator. All right, so again, if I didn't say this, all exponents should be positive when you're done. Okay, so here we'd want to get rid of that negative exponent by bringing it up. The 3 will stay up there, and then we bring the x up and change its sign. Same thing. Here we have a 3 at the top. We're going to bring the x to the negative 4 up and change its sign. And then the 5 will stay in the bottom. Okay? All right. So let's do some examples of 0, the 0 property. 0 squared, well, that's just 0 times 0 is 0. Okay? 2 to the 0, well, that is just 1. Anything to the 0 is 1. Here we have negative x to the 0. Again, this only applies to what's touching. You could write this as negative 1 times x to the 0. Well, that would be negative 1 times 1 or negative 1. Okay. All right, again, the 0 only applies to what's touching, so that would be 2 times 1, which is 2. Here again, we have 2 times 1 is 2. And here we have 1. Okay, so this parenthesis is telling us that that 0 applies to everything inside. So it would be like a negative 2 to the 0 and x to the 0. All right, and then here's some examples where we have negative exponents with no variables. Okay, in this situation, negatives, remember we bring them down. So that would be 1 over 0 to the 3rd. Well, that's just 1 over 0, which is undefined. Here we got 1 over 2 to the positive 4. And that ends up giving us 2 to the 4, which is just 2 times 2 times 2 times 2, which is 1 over 16. And again, these, you could probably just do it in your calculator if you get stuck. Okay, this is like negative 1 times 2 to the negative 3. Okay, so that only applies to the 2. So the negative 1 will stay up there, and we'll bring it down, bring the 2 down, and change the sign of the exponent. So that gives us negative 1/8. And then this, very similar. But this time we have a parenthesis, so the whole thing is going to go down, even the negative. So we'd have negative 2 to the positive 3. In this situation, we have negative 2 times negative 2 times negative 2. If you wanted to expand this, you could. You don't have to. That ends up giving us a negative 1/8. All right, and then we have 3 to the negative 2, so that's the same as 1 over 3 squared, which is 1/9. And then here, again, this negative 1 only applies to the 5. So we have a negative 1 over 5. Okay. If you have any questions on 0 property, let me know, or about negative exponents. Here's some where we have variables. So like these ones we can simplify for sure. Some of these, sometimes things with variables you can't simplify. Let's see if we can find any that we can't simplify. So these ones we have an exponent of a negative 3. So we want to bring that down and change the sign of the exponent. Again, this only applies to the x, so we have 2 over x to the 4th. Here we've got negative 2 over x to the 3rd. So this again only applies to the x, where this one applies to both, everything inside. So that would be 1 over negative 2x to the 3rd, positive 3rd. And then we just need to simplify the denominator. Okay, so we could rewrite this as 1 over negative 2x times negative 2x times negative 2x. And would end up getting 1 over negative 8x to the 3rd. Okay, often if we have a negative like that, we'd just bring it out in the front. So it would be negative 1/8x to the 3rd. Okay, here's some others. Again, negative exponents, so we'd root 1 over 3x squared. That ends up giving us 1 over 9x squared. And then the last one, the negative 5 stays at the top and the x goes to the bottom, because if we have a negative exponent. Okay, so if you need to refer to these on the homework, do so. And then we just have some practice. I did go over this on my first video, and then it didn't work out well. So if you need to look at that, you're welcome to. These are just some more examples. Nothing really different. The only other thing that maybe would be different is these that have decimals. If you have decimals, just do it in your calculator. Here we have, this is 1. X to the 0 is just 1. Okay, and then this last one, we have a negative exponent, so we need to bring that down. So that would be 1 over negative 0.4x to the positive 2. And then maybe we'd want to expand it and then simplify. Okay? So if you have any questions, let me know. I'd love to help you out. All right, we'll see you.